Dear students, we are solving ordinary differential equations with constant coefficients using Laplace transform. Now here we have a question. Solve y double dash plus 4y dash plus 3y is equal to e to the power negative t. And the initial conditions given are y of 0 is equal to 1 and y dash of 0 is equal to 0. Now let us solve this given equation by using Laplace transform, for which first we have to take Laplace transform on both the sides of this given equation. So on taking Laplace transform on both the sides of this equation, we get Laplace transform of y double dash plus 4 is a constant. So 4 multiplied with Laplace transform of y dash plus 3 multiplied with Laplace transform of y is equal to Laplace transform of, on the right we have e to the power negative t. So now from the formula we know that L of y double dash L of y dash is given by L of y double dash is given by s squared L of y minus s into y of 0 minus y dash of 0, and L of y dash is given by s L of y minus y of 0. Now let us substitute these two in this equation. So we get s squared L of y, that is for L of y dash we are substituting this, minus s multiplied with y of 0 minus y dash of 0, and we have a constant 4 here, so plus 4 has to be multiplied with L of y dash. But what is L of y dash? This term. So let us multiply 4 with this and we shall write, so 4 multiplied with s L of y minus, here also we have to multiply 4, so 4 multiplied with y of 0, and then we have plus 3 multiplied with L of y is equal to, on the right we have L of e to the power negative t. By using the formula under Laplace transform, we know that L of e to the power minus at is equal to 1 divided by s plus a. Now here we have L of negative t, which means a is 1. So therefore we will have 1 by s plus 1 over here. So 1 divided by s plus 1 we get on the right, because by the formula of Laplace transform. Now on the left we can gather L of y terms, that is we have L of y in these three terms, and if we combine and write it will be s squared. L of y we will take common, so plus 4s and then plus 3 multiplied with L of y, and then here if you see minus s into y of 0 we have. But what is the value of y of 0? It is given from the question, that is the initial condition y of 0 is equal to 1. So that we have to substitute. So when we substitute y of 0 as 1, that is this value is 1. So s multiplied with 1, so it will be minus s. And what about this value? It is given that y dash of 0 is equal to 0 itself. So from that this term vanishes, because y dash of 0 is 0. And then here we have again y of 0. What is y of 0? It is equal to 1. So minus 4 multiplied with 1. So it will be minus 4. And this is equal to 1 divided by s plus 1. Now further, here we have s squared plus 4s plus 3 multiplied with L of y. Let us take these two terms to the right. So we will get 1 by s plus 1, and negative s when goes on the right it becomes plus s, and minus 4 when it is taken to the right it becomes plus 4. We shall take the LCM on the right. So this will be equal to, the LCM is s plus 1, and so 1 plus, we have to cross multiply this s plus 1. So s multiplied with s plus 1 plus 4 multiplied with s plus 1. So this is what we get. We shall simplify this further. So 1 plus s multiplied with s is s squared, and then s multiplied with 1 is s, plus 4 multiplied with s is 4s, and then 4 multiplied with 1 is plus 4 divided by s plus 1. And so further this will be equal to, now s square, and then 4 plus 1 is 5, so plus 5s. 4 plus 1 is 5. So plus 5 divided by s plus 1. So on the left, what are we having? S squared plus 4s plus 3 multiplied with L of y. Now let us take this term to the right. So what we will get is L of y will be equal to, so we get L of y to be s squared plus 5s plus 5 divided by, bringing that to the right, it comes to the denominator. So s squared plus 4s plus 3 multiplied with s plus 1. We shall now factorize this. That is s squared plus 4s plus 3 we have to factorize. So 3 we have to use the Hill method. So 3 multiplied with the coefficient of s squared, which is 1. So we have to find the factors for 3 in such a manner that when you add it up, you get the coefficient of s. So 3 1 times is 3 and 3 plus 1 will give us 4. So therefore the factors are 3 and 1. So therefore L of y will be equal to, the numerator is s squared plus 5s plus 5 divided by, now we have found the factors for this. So we can write it as s plus 3 multiplied with, the other one factor is 1. So s plus 1, and we have this s plus 1. So that one we will write. So s plus 1. So therefore L of y is equal to s squared plus 5s plus 5 divided by s plus 3 multiplied with s plus 1 the whole square. So let us mark this as equation 1. Now by using partial fraction, we shall first find this, that is s squared plus 5s plus 5 divided by s plus 3 multiplied with s plus 1 the whole squared. Let us simplify it by using partial fraction. So when we split using partial fraction, it will split up as, the first factor is s plus 3. So a divided by s plus 3 plus, the next factor if you see, we have s plus 1 the whole square. So whenever you have a term with square, so first you should write the term as it is without the square, and then the third term will be with the square you have to write. So this is by the method of partial fraction. It is by that method we have directly done it. So this is what we get. Now we have to find the value of a, b and c in order to evaluate these terms. So how to find that? If we take the LCM, on the right we get this same denominator as on the left. So that get cancelled and we get here the numerator is s squared plus 5s plus 5 is equal to a multiplied with, now the LCM is what? S plus 3 and s plus 1 the whole squared. We have s plus 3 over here. So what we have to multiply s plus 3 with? S plus 1 the whole squared, and so a will be multiplied with s plus 1 the whole square plus b multiplied with, we have one of the s plus 1 over here. So the remaining will be s plus 3 multiplied with s plus 1. Okay, plus c multiplied with, if you see we have this denominator of c as s plus 1 the whole square. So what is the other term left out? S plus 3. So c multiplied with s plus 3. So if you know the method of partial fraction, you will understand this more better. So this is how we have to do it. Then now we have to find the values of a, b and c. In order to find the value of a, we can put s is equal to minus 3 so that these two terms will become 0. So put s is equal to minus 3. So what about the left hand side? Minus 3 square. So minus into minus will become plus, and 3 square is 9 plus. Here if we substitute minus 3, you get minus 15. So we have minus 15, and then plus 5 is equal to a multiplied with, so s if you put minus 3, it will be minus 3 plus 1, which is minus 2 the whole square. So what is 9 plus 5? It is 14. So 14 minus 15, which will be minus 1, and that will be equal to a multiplied with, what is minus 2 squared? It is 4. So from this we get the value of a to be equal to negative 1 by 4. So we have obtained the value of a. Next we have to find the other value, that is in order to find the value of b, for example, or first it will be easy to find c because these two terms has s plus 1, s plus 1. So if you put s is equal to minus 1, these two terms will vanish and easily we can find the value of c. So for which we have to put s is equal to minus 1. So if you put s as minus 1, what about the left hand side? Minus 1 squared, which will be 1, and then 5 into minus 1, so minus 5, and then plus 5 is equal to, so if you put minus 1, this term will vanish. Here also if you put minus 1, this term will vanish. So c multiplied with minus 1 plus 3, which will be 2. And so here you have 1 is equal to 2c. So therefore we get the value of c to be equal to 1 by 2. So we have obtained the value of c. Next we have to find the value of b, for which we have to, if we want to find the value of b, we have to compare the coefficient of s square on both the sides. That is, on the left, what is the coefficient of s square? It is 1. So here you have 1, and that is equal to, on the right, here if you expand s plus 1 the whole square, you will get one of the s square term, and when a is multiplied with it, you get as square, and so the coefficient of s square for this term will be a. So that we have to write. Then we have a plus, so plus, and the coefficient of s square over here will be b, because when this and this is multiplied, you get an s square, and this constant b, when it is multiplied to it, you get bs square, and so therefore you will have a b over here. But do you have an s square over here? No. So you need not write this value c. So from this, we will substitute the value of a that we have already obtained. So 1 is equal to, a is what? Minus 1 by 4 plus b. So from this, we get b to be equal to, taking this to the other side, 1 plus 1 by 4. And so the LCM is 4, and the 4 plus 1 is 5. So therefore, we get the value of b to be equal to 5 by 4. So we have obtained the value of a, the value of b, and the value of c, and so therefore we can substitute it over here, that is this one. So when we substitute, we get the right hand side of equation 1. So therefore L of y will be equal to, so let me write that now. So L of y is equal to, a, what have we taken? A divided by s plus 3. What is a? Okay, so where is a? It is here, negative 1 by 4. So minus 1 by 4 divided by x plus 3. I'm sorry, s plus 3. So s plus 3. The next one is plus, next term is what? B divided by s plus 1. So what is b? 5 by 4. So it is 5 by 4 divided by s plus 1, plus the next term is c divided by s plus 1 the whole square. So what is c? c is 1 by 2. So 1 by 2 divided by s plus 1 the whole square. Now from this equation, we have to find the value of y, for which we have to take this L operator to the right. So when it goes to the right, it will become, so y will be equal to Laplace inverse of minus 1 by 4 divided by s plus 3, and then plus 5 by 4 divided by s plus 1, plus 1 by 2 divided by s plus 1 the whole square. Now we have to take the Laplace inverse of each of the terms separately, first term, second term, and third term. So let us separate them, because it accepts the linearity property. So after taking Laplace inverse transform of each of the terms, we get this. Now here we shall apply the Laplace inverse transform of these terms. So y will be equal to negative 1 by 4. What is Laplace inverse of 1 by s plus a? So Laplace inverse of 1 by s plus a is e to the power minus at. So here the value of a is what? 3. So e to the power minus 3t will be the answer for this. Plus this 5 by 4 we will write as it is. Laplace inverse of 1 by s plus 1. We are going to use the same formula, that is Laplace inverse of 1 by s plus a equal to e power minus at. Now here the value of a is what? Here the value of a is 1. So e power minus t. So it will be e to the power minus t plus 1 by 2. Now here we have to apply the shifting property under inverse Laplace transform. That is, here we have inverse Laplace transform of 1 by s plus a the whole square. So when as is shifted to s plus a, we have to write it as e to the power negative at multiplied with Laplace inverse of, now shift s plus a to s itself. So Laplace, if you shift s plus a to s, it will become 1 by s square. So Laplace inverse of 1 by s square. So this is the formula. Now at the place of a, what are we having? We are having 1. So when we apply it over here, we get e to the power negative t multiplied with L inverse of 1 by s square. So e to the power negative t multiplied with Laplace inverse of 1 by s square. The problem is still not done because here we have a Laplace inverse which we have to apply. So negative 1 by 4 e to the power minus 3t plus 5 by 4 e to the power minus t plus 1 by 2 e to the power minus t. And what is inverse Laplace transform of 1 by s square? By the formula we know that it is equal to t. So using this we have t over here. So this is the solution for the given ordinary differential equation which we have solved using the method of Laplace transform. Hope you have understood this problem. Kindly follow the next video lecture for problem 4 under the same topic. Thank you.